In this video, I'm going to go over the zero exponent law. Okay, so the zero exponent law says that if anything is raised to the power of 0, it is equal to 1. So for example, 5 to the power of 0 equal to 1. X to the power of 0 equal to 1. Doesn't matter what it is. For example, I will go into Desmos and show you. I will type in a random number. To the power of 0, it equals 1. Anything to the power of 0 equals 1. It's my favorite law because it's the easiest one, right? Okay, so notice here that over here, this entire thing, in parentheses, I got to get rid of it, right? When in order to get rid of it, I got to distribute the exponent on the outside. But the exponent on the outside is a 0. If I distribute this to every single thing in here, this entire thing is going to equal 1. So you're going to have 3x squared times, essentially, 1. Right? This entire thing equals 1 because it's been raised to the power of 0. Anything raised to the power of 0 is equal to 1. Now I can show you in a more complicated way, right? 5 times 0 is 0, right? Because we're distributing, we're doing the power property here. So 0 times 5 is 0. 0 times 3 is 0. 2 times 0 is 0. So all of these are to the power of 0, which is going to be 1 times 1 times 1, which is just 1. So all of this just equals 1, okay? So what's 3x squared times 1? Just 3x squared. So anything raised to the power of 0 is equal to 1. Number 2, this one's a lot more complicated looking, but again, it's all about simplification. Don't distribute that 1/3 on the outside. I know you see it, but save it for last. Any type of distributing you want to save for last. So you want to combine anything you combine before you make it more complicated on yourself. So, any like bases here? Well, 3 and 9 are like bases. They're regular numbers. 3 times 9 is 27. Okay? The next thing, you want to look for like bases. X cubed. Well, x cubed and x cubed, right? We're going to add those together. Why would I add and not multiply? Because I'm not distributing anything. If I'm distributing, then I multiply. So it'd be x to the 6 because it's 3 plus 3. We have y to the 5th. And then y to the negative 2. Well, y to the negative 2 here, I'm just going to combine it with the y to the 5th. Now, I would do that by adding. 5 plus negative 2 is going to be positive 3. And then I have z to the 0 and z to the 9th. Now, just because there's a 0 there doesn't mean that you treat it any differently. You're still going to add those numbers. What's 0 plus 9? 9. So you have z to the 9th. You're like, well, you basically didn't even need this, right? Because I just have this. Remember, z to the 0 technically equals what? It technically equals 1. And does 1 have any use to us when we multiply to things? Not really. So we could have just erased it at the beginning if we really wanted to, right? I do that with my AB kids sometimes. If you see something raised to the power of 0, just basically scratch it out. It's basically useless to us. It's equal to 1. Not equal to 0. It's not like it goes away. It's still there. But multiplying something by 1 changes literally nothing, right? 1 times xyz is just xyz. 1 times 5 is 5. So the 1 is not necessary to write, which I'm fine with if you want to just like get rid of it at the beginning and write a 1 there. Times 1, because that's what it equals. Okay, now I've combined all of my bases together, but I have not distributed the exponent of a 1/3 yet. So let's go ahead and do that. Now, here I am distributing, which means I'm going to be multiplying. That's the operation of multiplication. Now, we have z. I don't know why I'm doing this in the color black, because everything's going to look very sloppy, because they will all be one color. So let's do baby blue. Now I'm going to have z, and then do 1/3 times 9. Remember, you can type that into Desmos. 9 times 1/3. Oh, my goodness. 9 times 1/3. 9 times 1 divided by 3, which is 3. Okay. Next thing is, I got to use a different color. You have 3 times 1/3, which is just 1. Now, you can write y to the first power if you want to, or you can leave the 1 off. Up to you. Next thing is 6 times 1/3. That is going to be positive 2. 6 times 1/3 is 2. And then lastly, we have 27 to the 1/3. It is not 27 times a third, people. It is not. It is 27 to the 1/3. So 27 to the 1 divided by 3, it equals 3. Okay, so 27 to the 1/3 equals, let me move this problem down, it's a little too high. 3, and then we have x squared yz cubed. And that is in simplest form because we only have one of every base. Again, it's all about simplifying, right? It looked really complicated at the beginning and then it ended up being not that much. And then our last example here, we have 8v to the 0, u to the third divided by 4, u to the 7th. Now, you want to look at each individual part. Just like I mentioned in the quotient law video, you want to look at each individual part of the fraction separately. So if I look at the top, can't simplify. Look at the bottom, can't simplify. So then you combine. So I know that I can do 8 divided by 4. Well, what's 8 divided by 4? It's 2, right? It's 2. 2 over 1 technically, right? 2 over 1. Now, do you have to write the 1? No. Next thing here, I see that I have a v to the 0 in the numerator. Now, I can't combine it because there's no other v, so I'm going to go ahead and leave it there as for now, right? I'm going to leave v to the 0 there for now. And then I see that I have u's on both sides of my fractions, u to the third and u to the 7th. Where are there more u's? In the denominator. How many more? There's 4 more. 7 minus 3 is 4. Now, remember what I said. Anything raised to the power of the 0 is equal to 1. So this actually is just times 1. Well, what's 2 times 1? 2. So you basically didn't even need it to be there.